Hey guys, this is Mr. Brengle, and today I'm going to be going over the speed practice problems for ICP. So we've got our first problem here. It says calculate the speed for a car that went a distance of 125 kilometers in 2 hours time. So the first thing we want to do is highlight or underline the important parts. So it says calculate the speed. Right, so that's going to be our unknown right off the bat, and I'm going to go ahead and I'm going to get my givens and my unknown right here, and so I'm going to go ahead and put that v equals question mark, and then we'll put the units in here in a second. Okay, it says the car that went a distance of 125 kilometers, so that's important, and then 2 hours, right? So that gives us our two givens. We've got distance is equal to 125 kilometers, and then we also have time is equal to 2 hours here. So this tells us that for our speed, the units here are going to end up being in kilometers per hour. Okay, so the next thing we want to do is write out our equation, and we know that for speed, that is distance over time. All right, step 4 here. We're going to go ahead and substitute our values in. So v is equal to 125 kilometers. Whoops, that's a bad m, but that's okay. Over 2 hours. So when we solve this, you plug 125 divided by 2. Should come out to be 62.5 kilometers per hour. All right. Let's go ahead and move on to the next problem. All right, so this one says a baseball is thrown a distance of 20 meters. So right there, it's given us something. Distance is equal to 20 meters. What is its speed? Okay, so that was the unknown right there. It said, what is its speed? So v equals question mark. If it takes 0.5 seconds to cover the distance. So here the time is 0.5 seconds. And this tells me that my units here are going to be in meters per second. Now, next thing, we're going to do our equation. Again, we're solving for velocity, or speed rather. So make sure that you've got v equals d over t. Let's go ahead and substitute our values in here. Speed is equal to 20 meters divided by 0.5 seconds. And we'll go ahead and solve this. Dividing by 1/2 is the same as multiplying by 2, but if you go ahead and plug 20 divided by 0.5 in your calculator, it is going to give you 40, and then our units here would be meters per second. All right, I know this got cut off just a little bit, but it'll be okay. So how much time does it take for a bird? We can go ahead and stop there because it's actually already given us something. It gave us the unknown. It says how much time does it take? So we are solving for time. It says how much time does it take for a bird flying at a speed of 45 kilometers per hour? So v is equal to 45 kilometers per hour to travel a distance of 1,800 kilometers. So d is equal to 1,800 kilometers. Now, based on this, I know that my time is going to be in hours because it gave me speed in kilometers per hour. So now I'm going to go to my equation. Now, if you know how to manipulate the equation and you just want to put the equation on there that starts t equals, that's fine. I'll go through how to manipulate it here. So v equals d over t. Okay. And then if I want to get t off of here, I need to get t out of the denominator, so I need to multiply by t on both sides. Okay, that's going to cancel these two out. And now you're left with TV is equal to D. But we're not done. We're trying to solve for t. We got to get that by itself. So let's divide both sides by v now. These will cancel out. And now we have t is equal to d over v. This is the equation we want to use. So now we can substitute our values in. T is equal to the distance, which is 1,800 kilometers, over 45 kilometers per hour. Now, if it doesn't make sense to you how your units are coming out right, you know, this part you don't need to do, but I'll just show this. I could rewrite this as 1,800 kilometers, can't write M's today, over 1 times 1 hour over 45 kilometers. Okay, so all I did is I flipped this right here. I'm still dividing by 45, but now it's going to help me cancel out my units, and you can see that we'll just be left with hours. So go ahead and do 1,800 divided by 40, and it should, oh, whoops, sorry, 45. 1,800 divided by 45, and this should come out to be time is equal to 40 hours. All right, we'll go ahead and move on to the next one now. Okay, so it says a comet is cruising through the solar system at a speed of 50,000 kilometers per hour. So that just gave us speed here. V is equal to 50,000 kilometers per hour. And then it says that this is occurring for 4 hours time. So that is another given. Time is equal to 4 hours. All right, now for the unknown, it says what is the total distance traveled? So we are now solving for distance. And this is going to be in kilometers because that's what we have for our velocity, kilometers per hour. So again, I'll go through how to manipulate the equation here. Okay, we want to get d by itself, so we need to multiply by t on both sides to get that out of the denominator. Okay, and that actually is going to give us the equation we want. D is equal to TV, or VT, doesn't matter which order you put that in. All right, so now we can substitute. D is equal to the time, which is 4 hours, times the speed, which is 50,000 kilometers per hour. And you can see here that the hours are going to cancel out, right? And we're just going to be left with kilometers. So we're just going to multiply 50,000 times 4, and it should be 200,000 kilometers. All right. Go ahead and move on to the next page. Okay, so if Steve throws the football 50 meters in 3 seconds, so it actually just gave me two things there, two givens. All right, it gave me the distance is 50 meters, and then it also gave me the time, it's 3 seconds. What is the average speed of the football? Okay, so we know that we're solving for V, and since it gave me meters and seconds in the distance and time, I know that these units are going to end up being meters per second. So now I'm going to go to the equation, and we don't have to do any manipulating here. V equals d over t. Go ahead and substitute in 50 meters divided by 3 seconds. And your speed should come out to be 16 point, and if you round, 67 meters per second. All right, moving on. All right, so it says if it takes Ashley 3 seconds to run from the batter's box to first base, so that's a given, right? Time is equal to 3 seconds. At an average speed of 6.5 meters per second, So that gives us the speed, the average speed or the velocity of 6.5 meters per second. All right, what is the distance that she covers? So d is what we're solving for, and since we have a speed of meters per second, then we know that our distance is going to be in meters. Okay, so let's manipulate that equation again. We got to get t off of the right side, so we need to multiply by t on both sides. That'll cancel out on the right, and that's going to give us distance is equal to t times v. Okay. We can now substitute our values in. Distance is equal to the time, which is 3 seconds, times 6.5 meters per second. So the seconds will end up canceling here. And then you should get a final distance of 19.5 meters. All right. Okay. So Bart ran 5,000 meters, so that's going to be a distance. So D is equal to 5,000 oh, whoops, that's 500. 5,000 meters. Bart ran 5,000 meters from the cops at an average speed velocity of 6 meters per second. Okay, so that gives us the speed as well, 6 meters per second. Before he got caught, how long did he run? So how long did he run is asking for a time. All right, and since it gives us our speed in meters per second, I know the time is going to come out to be in seconds. So let's go ahead and manipulate this equation again. Remember, we got to multiply by t on both sides to get that out of the denominator. So now I have t v is equal to d, but I'm solving for the time, so I now need to get rid of the velocity. So I'll divide by the speed or velocity on either side, and that's going to give me time is equal to distance over speed. Okay, so this is what we're going to use. Now I can go to my substitute step. Time is equal to the distance, which is 5,000 meters, over 6 meters per second. All right. So when we solve here, this should come out to be 833.33 seconds. Let me actually make this over here. Okay, there we go.